So with the radical equation, our goal, and this should be the very, very first thing you do. Sometimes this is already the case, but if it's not, your goal is to get the entire radical alone. Okay, you're going to isolate the radical. Sometimes all of your stuff will already be in the radical and nothing on the same side will be outside. Okay, if that's the case, we kind of reverse the order in which we do things. But in this case, you've got radical x minus 3. So negative 3 is outside. You have to think of that radical as kind of like a chain that's padlocked. You can't do anything to what's inside until the radical is gone. Okay? Less important here, but when there's other stuff besides x, you can't add, subtract, multiply, or divide it out until the radical's gone. So the first step here is going to be like what you would normally do to get x by itself, except we're getting the radical by itself. So what would you do to get rid of negative 3?
Plus 3.
You're going to add 3. So we get the square root of x is 7. So our first goal is satisfied. We got the radical alone. Once that happens, okay, in order to undo the radical, you just finished a couple sections on radicals, and you hopefully are starting to figure out that a radical times itself gets rid of the radical. We get what's inside, right? Unfortunately, you don't want to multiply both sides by radical x because you'll only be complicating what's on the right side, yes? But there's another thing that we can do which doesn't bring our radical x to the other side. To undo a radical, we're going to square both sides. Okay? And as you go through more math, hopefully you start to have it in the archives or somewhere handy that squaring a radical undoes the radical, just like taking the square root of something squared undoes the square. They're inverse operations of each other, okay? So these two cancel each other out. Think of 2 as like a key that unlocks the padlock and gets rid of the chain, okay? Falls away and whatever is inside is what you have left. So squaring a square root gives us what's inside. Nothing inside changes. You don't get x squared inside. You just get what was inside. Okay? But on the right, we really do have to square 7. So we get 49. Okay? So if there's anything left that was inside the radical, at that point you finish solving for x. Yeah. Yes.
Go ahead. What are you doing? What? What are you doing? Are you doing it? What are you going to build on?
All right. He's going to take notes. Okay. So now, for at least a portion, not quite half, but almost half of your homework, you are going to check these answers. So, because part of 11.3, you're required to do it, and you'll understand more later, but you're going to check your answer by substituting in the solution for x. Okay. The thing you need to remember here is a lot of people, when they sub in to check their solution, they start doing solving steps again. Don't solve, because some of the solving steps that you did might cause there to be solutions that don't work to begin with. So what I mean is you're going to go back to the original. We're going to plug in 49 in place of x. Don't do stuff to both sides, okay? You're only going to simplify each side separately. So the square root of 49 is 7. And then 7 minus 3 is 4. You should not be doing anything to both sides, okay? When you're checking, you want to avoid doing that. Okay, that works out. So I want you to take a second. You're going to do this one. It's similar to the one that we just did. Okay. Solve, check your answer, make sure it works. And then we're going to do a couple more because there's slight variations of this. So what's the first thing that I do? I add 4 because it's outside the radical, and I want to get the radical alone, so I get radical x equals 9. And then what?
Square both sides.
Square both sides. So x equals 81. And I'm going to check that. So I get the square root of 81 minus 4 equals 5. 9 minus 4 equals 5, and 5 equals 5. Okay. The nice thing about these is if you take the time to do it on a quiz or a test, you really should know before you ever turn it in whether or not you have those correct. Because if you plug something in and it doesn't work, that's not the time to fudge it and make it look like it worked because I said check your answers. Okay. The whole purpose is to make sure you have the correct answer. Yeah.
Can't you just skip the step where you like square it and like take that number and five so you know what that's going to it's not a square, it's like, how you subtracted 7 and 3 and you subtracted 9 and 4 like 9 and 7 would be
Yeah, but they're not all going to be like this. You know what I mean? They're not all going to be just the variable and the square root. That's why you should do whatever you see in front of you, like plug it in and then go and simplify from there. Because they do get more complicated than this. All right, so here's where some of the variations come in. What's different about this from the last two that we looked at?
The last two numbers in the radical.
Yes, both, you have two things in the radical, not just one. Here, there's nothing outside the radical on the same side. So the radical is alone. We said our first goal was to get the radical by itself, right? That's done. So you move on to the second thing is the radical's by itself. So we immediately square both sides. Okay? Now, remember, I said this is like a chain holding a bunch of stuff together. If you unlock that chain falls away, you get what was inside. You don't square anything in here. So we get x minus 2 when we square that. On the other side, we get 36. But you're not done because you do need to finish solving for x. So now we add 2. So x equals 38. Okay, if you want in the checking process, if you want to say, well, I know I'm going to do 38 minus 2 in the radical, so that's 36. You know, you can skip part of that and say, well, I know that that's 36 equal to 6. So I'm really plugging this in for x, but it's still in the radical, and then the square root of 36 is 6. Okay. So show that you're checking it in some way, shape, or form. If you skip a little bit, that's fine, but I want to see that you're checking these answers. All right. Okay, so these are all just variations. Okay, this one is slightly different yet. How would I start out this one? These are combined by multiplication. So you have to undo multiplication, which is division. Okay, so I get radical x equals 4. And as soon as your radical is alone by itself, we square both sides. So x should be 16. To check this one, we have 2 times the square root of 16 equals 8. That would be 2 times 4, right? Square root of 16 is 4. So 8 equals 8. Yes?
On my homework and quizzes and stuff, do you have to like write down what you're checking so we work?
Yeah, they're going to be, part I'm going to make you do it. So the bookwork 1 through 8, I'm going to make you show checking it. But you're going to have a worksheet also. You don't have to check the rest of them on paper. Okay. But I want to make sure you guys are doing it and doing it correctly. Right. So these, it's a little easier to check it mentally. The reason I'm going to have you get in the habit with some of them is because 2 days from now, we're going to be doing ones that do come up with solutions that don't work. And if you don't check them, you're not going to know which ones work, or you know what I'm saying. And some appear at first like these, and you might think, oh, I know these kind of always work if I solved it correctly. But they appear like they should, but when you plug it in, they really don't. So, yeah, Josh?
Well, how's A equals A equal X equals 16?
This is not your solution. We plugged our solution in. If your solution is correct, plugging it in makes your equation true, right? We're not solving over here. We solved and got 16. So 16 should make this true. You know what I mean? So if I plug it in and I got 5 equals 8, then that's not true. What I plugged in would not be the correct solution because it didn't make it true. There's only one correct solution that makes it true. Well, eventually there might be 2, but that's a whole different story. Okay, one more. All right, so this is different yet than any that we've done. The 2 is on the inside of the radical with the x, not on the outside like the one we did 2 problems ago. But this is on the outside. So what would you do first? You'd add 2. Because the radical's not alone. You should not be squaring anything until the radical's alone. So we get the square root of 2x equals 12. Now the radical is alone. So you go ahead and square to get rid of the radical. And those just undo each other. Don't be tempted to actually do any squaring there. This would be 2x, but this would be 144. You're going to divide out the 2 to finish it up. So x is 72. And then we're going to go back up to the original to check it. So you're going to have the square root of 2 times 72 minus 2 should equal 10. So that's the square root of 144. Okay, square root of 144 is 12. And 12 minus 2 is 10. So it works. Okay, now if you got down to the bottom and you got 8 equals 10, that doesn't work. Don't go back and change something here because you're like, nope, I want it to work because I don't want to fix my problem. If it doesn't work, that's telling you you did something wrong. Okay, it should work if it's your solution.